I've shared with you a document called UnitCircleInDesmos, and we just completed a chapter that shows how the graph and the sine and cosine function look like waves, but how does that relate to the points that are on unit circle? So if you click this link down here, it opens up this Desmos page, and the equation of a circle of radius 1, i.e. the unit circle, is x squared plus y squared equals 1, and when you solve for y, you get these two solutions. So this graph right here is the top of unit circle, and this graph is the bottom. So notice that if I ask for a point cosine of t and sine of t to be plotted, and I have inserted a slider for t, which can act as t, theta, or theta, the angular rotation from that central angle, instead of rotating in degrees, even though we could interpret each one of these as 15 degrees, they are pi over 12 radians. So you can see that the maximum value of the slider is 2 pi. So when I slide this all the way around, you can see how we're going all the way around unit circle. So if I start back here at 0, cosine of theta, which is 0, is 1, and sine of theta is sine of 0, which is 0. And so that's what the ordered pair is plotted. So that's point right here. This red point is being plotted at the slider. But I not only have the radius and the point on unit circle being plotted, but I have shown the two legs of the appropriate right triangle that's embedded in unit circle in these dashed orange lines. And you can see that the x and the y values are exactly those lengths. So since theta is between 0 and pi over 2, otherwise known as 90 degrees, all these are points in the first quadrant. So you notice that both the cosine and sine x and y values are positive. But as I keep rotating past pi over 2 into quadrant 2, this value is theta is a radian equivalent of 105 degrees. And so now you can see that this is a positive y value for that reference triangle, but this x value is negative because we're in quadrant 2. And I can keep sliding over, and you can see how it's drawing all the related reference triangles and the related side lengths of each of those. So this is a 210 degree rotation. That's 7 pi over 6. If you were to multiply by pi by 7 and divide by 6, you would get this number, 3.665 da 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 da. And so that is basically the decimal approximation of 7 pi over 6. This is a 210 degree rotation. You can see it's 30 degrees more than 180. So this reference angle is 30. So this length is rad 3 over 2, and this is 1/2. But since we're in quadrant 3, both the x and the y values are negative. You can notice here that the cosine and sine values are both negative. So if I keep rotating past 270 degrees, now I'm in quadrant 4. And let's just go to this angle right here. That's 315 degrees. It's 45 degrees shy of 360 degrees, so that's a 45 degree reference triangle. So both of these lengths are rad 2 over 2, which is about 0.707. But the x value is positive and the y value is negative because we're in quadrant 4, where this point is got a positive x value and a negative y value. So we can keep rotating around. This is, if you were to only focus on just the x values of all those little line segments that are the legs, you would see how it's related to the height of the cosine wave as you are going through the 4 quadrants. Similarly, if you were to focus on the y values of all of these reference triangles, the dashed lines that are orange that are the opposite side length in here, those are a proportion of the radius of 1 that is in terms of the sine values. And so if you were to focus on all those y values being positive and negative, you can see how that's related to how the sine wave is above the x-axis, then below, and then back above it. This is a really nice way to kind of visually see how unit circle helps us to better understand the outputs for both the cosine and sine values through the relationship to the unit circle.